Good day, students. Today I want to solve problem that involve graph of linear inequalities. When you are solving problem like this, you have to take notes of some things. When you are drawing your graph, you can see that you have to solve simultaneously by drawing the graphs 3x plus y less or equals to 11. When you have less or equals to in the equation, you use thick line to show that it's less or equals to. But if it is only less than or greater than, you use dotted line. But so far you have greater than or equals to, you use thick line, or less than or equals to, use thick line. Okay, now what you having, let's start drawing the graph. But before we start drawing the graph, we have to take notes by saying, okay, let's start with the first one. 3x plus y less or equals to 11. Now let's say when x equals to 0, what is y? Now the 3 into 0, because we assume when x equals to 0, you replace it back where you have x plus y less or equals to 11. 3 times 0 is 0 plus y less or equals to 11. Therefore our y is less or equals to 11. Okay, that means that when x equals to 0, y equals to 11. Okay, let's go to the second one. 2x minus y less or equals to 4. Okay, now before then we have to do the other side. Now we have assumed when x equals to 0, what will be y? Now let's see when y equals to 0. Now we have to do it in two ways. When y equals to 0, what will be the value of x? 3 into 0, 3x plus 0 less or equals to 11. Okay, now 3x plus 0, that's 3x less or equals to 11. Divide both sides by 3. 3 cancel 3. X is less or equals to 11 divided by 3. That was 3.67. Let's see, 11, use 3 to divide it. 3 times 3, 9. I mean 2. 3 goes into impossible, put point, put decimal. 3 goes in 26. 3 times 6, 18. You have 20 or so. 666, just as approximately as 3.67. Okay, which is approximately 3.7. okay, we have when y equals to 0, x equals to, when y equals to 0, x equals to 3.7. okay, now let's see the second half. That's 2x minus y less or equals to 4. Let's see when x equals to 0, what will be our y? Let's substitute 2 into 0 minus y less or equals to 4. As 2 times 0 is 0 minus y less or equals to 4. Minus y less or equals to 4. Divide both sides by minus 1 minus 1. When you do that, when you are dividing both sides by negative, the sign will change to greater or equals to from less or equals to. We're having y to be greater or equals to minus 4. Here when x equals to 0, y equals to minus 4. Okay, let's see when when y equals to 0, what will be our x? We're having 2x minus 0 less or equals to 4. We're having 2x minus 0 is 2x less or equals to 4. The variables are by 2, 2 here 1, 2 here 1, 2 here 1, 2 here 2. X is less or equals to 2. Here you can now say when y equals to 0, x equals to 2. When y equals to 0, x equals to 2 for the second one. Now let's now see the third one. X greater or equals to 0 and fourth one, y greater or equals to 0. We can now plot the graph now. This is a positive y, negative y. This is positive x, negative x. Okay. From here now is this is positive x and this is negative x axis, and from here this is negative, from here positive, from here negative y, positive y axis. 1, 1. Okay, let's make it bigger. 1, 2. Well, we have the limit value for y to be minus 4. Having minus 1, minus 2, minus 3, minus 4. The highest value for x is 3.7. This is 1, 2, 3, 4. 3.7 will be around this area. For the negative side, you have negative value of x. And they have negative x. We don't have. Okay, now let's now start plotting. From here above is greater than, you can see is greater than 0. If you say x greater or equal to 0, this thick line that is straight shows that is greater or equal to 0. Let me say you are told that x is greater than 0. You turn this on to dotted line. Okay, because of there's no equals to, but we have greater or equals to, because if it is greater, the x-axis will be dotted, but if it is greater or equals to, it will be thick line throughout. Okay, now let's start the plotting. We're having for the first linear equation, when x equals to 0, y is 11. Okay, you see that we're having the highest value of y to be 11. Can now try to this is, I make it 2. Okay, since we have made this one to be 1, 2, let's make it so that it can go round. We're having minus 2, minus 4. Okay, this one will be 2, 2, 4, 2, 4, 6, 8, 10, so it will be 12. Let's make it 2 units. This is 12. 11 will be in between. Okay. When x is 0, y will be 11. Let's start the middle. 0, y is 11. And when y is 0, x is 3.7. Y is 0, the same point. You trace it to where we have 3.7 positive to be around this side. 3.7. Now use tick line because it is less or equals to. Now use tick line. If it is ordinary less, it use dotted line. Now, how do we know where to shade? You can either use the condition given to us, that is, if it is less or equals to, you leave the less and shade the opposite of it. Now, you can see it's moving of this greater, less value is moving towards down, that's less. But we want to shade the opposite of the less, which is greater. Okay? Moving up is greater. So shade the opposite. Okay? We have finished with this one. Can now write on it that 3x plus y less or equals to 11. Let's go to the second one. When x is 0, y is minus 4. When x is 0, y is minus 4, you start it. And when y is 0, at this point also, x is 2. Trace it. Okay? Because it's less or equals to, what of that equals to, use tick line. Okay, how do we know where to shade? We are trying to shade the opposites of what you are having. We have less or equals to 4, but less or equals to 4. This is less or equals to, this is less or equals to 4. The reason why we are going to shade this one is that it has turned, when we divide both sides by negative, it turns to greater or equals to, we're interested in greater or equals to minus. For this sign changes, we now shade less. You can see you have it has changed to greater or equals to. That's why we are interested in greater or equals to, which is from here is greater. Moving up, we shade the opposite. Okay, divided by negative has changed the sign from less or equal to greater or equals to. That is, we are interested in greater or equals to. We shade the opposite, and that one is 2x minus y less or equals to 4. But don't forget that we are using this okay. Next is that we use x greater or equal to 0. X greater or equal to 0. We're interested in greater or equal to 0. You now shade this from here is greater because it's 1, 2, 3, 4, 5. They are higher numbers, but when you are coming here, you are having -1, -2, -3, -4, and so on. These are less. We're interested in greater than 0. You shade this side, because this x-axis, you can see it. Now write it there, x greater or equals to 0. Okay, and let's see y greater or equal to 0. We're interested, this from here is y is equal to 0. You can see the thick line showing that it's greater or equals to. Now from here up is higher number, 2, 4, 6, 8, 10, greater than 0. But when you look at it from here, you have a -2, -4, which is less than 0. We leave the one we are interested in. You shade from here down, because we are interested in greater or equal to 0. As y greater or equal to 0. This place is the required region that is not shaded at the middle. Required region. Okay, there are some cases in which where we shaded will be what, where all the three equations, the three inequalities where the line crosses each other, the three line crosses each other, can also be taken as the required region. Okay, in the next class we are going to see where three lines crosses each other. In that case, we are going to use where we're considering where the sign is being given, not the opposite of it. Okay, this is the end of our class. Please subscribe to my channel so that you can have access to the latest video. Have a wonderful day.